All right, so in this video, we're going to find and simplify the difference quotient for a polynomial function. We're going to start with an x squared function, and then when we're done with that, we'll say a little bit about what happens if you have higher degree polynomials. But the basic process will otherwise be similar. So the first thing that we're going to calculate is f of x plus h. Now, remember that for function notation, what this means is that everywhere in our original formula, our original function, wherever there's an x, we need to replace that x with x plus h. It is not f of x, and then you just stick h out on the end. That's not going to work. What we need to do is replace x with x plus h. So I had x squared, so this will be x plus h squared. I had minus 5x, this will be now minus 5 times x plus h, and then the 11 doesn't have an x on it, so that doesn't change. Now, it's useful sometimes to do the algebra first and then put everything together, because when you do all the algebra all together inside the difference quotient, sometimes that can be a little overwhelming. It seems like a really big, messy problem before everything starts canceling. So we're going to break this up into a few steps. So I'm going to do the algebra for this first. Now, one thing to keep in mind, x plus h quantity squared is not x squared plus h squared. This is wrong. Your problem will not simplify properly if you do this. Powers do not distribute through addition or subtraction. You can't do that. So what you have to do is you have to FOIL, or remember that there is a formula for perfect square binomial. And in this case, it's the first term squared. It's 2 times the 2 terms multiplied together, and then the last term squared. That's the formula. So our f of x plus h is going to become 3 times x squared plus 2xh plus h squared minus 5 times x plus h plus 11. And if I simplify one more time by doing my distributing, 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 11. Now, again, keep in mind that 3 that's out front, order of operations says you have to square and then multiply. So you can't put the 3 through the parentheses and then square, because you'll end up multiplying by 9 and not 3. First square, do the foiling, apply your perfect square formula, and then distribute the 3. So that's our f of x plus h. So now what is our numerator? F of x plus h minus f of x. So that's just minus the original function. So that's our thing that we just found. 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 11 minus, and then in parentheses, 3x squared minus 5x plus 11, because you have to distribute that negative sign. So that's going to get us 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 11 minus 3x squared plus, because minus minus, 5x minus 11. Now, some of this is going to simplify. So let's see what simplifies. Let's color code them. We have, no, that wasn't what I wanted to do. Let's try this. There we go. 3x squared and minus 3x squared. They're gone. 5x. Try a different color. And negative 5x. They're gone. And also 11. Try a different color. and negative 11. Also gone. So what do we have left? 6xh plus 3h squared minus 5h, and that's it. Now, the thing to keep in mind about problems like this with the difference quotient is all the terms that do not have h on them should cancel. That's sort of the whole point, honestly. They have to cancel. If you have terms left over that do not have an h on them, you have made an arithmetic mistake. So this is one place where you can check, am I doing this right? Do I have only terms that have h left? There's a good chance that you are okay if that's the case. And then finally, we put all of it together. The entire difference quotient is going to be our numerator that we have left, because this expression is just this numerator. It's going to be 6xh plus 3h squared minus 5h divided by h. Be careful how you cancel. Again, it's sort of tempting to just kind of splash, but you have to be careful to make sure that you cancel an h on every term, because division and multiplication cancel each other, not addition and subtraction. So we're going to factor out an h, 6x plus 3h minus 5 divided by h. And now our h's can cancel. And so we're left with 6x plus 3h minus 5. All right, so how does this get more complicated potentially? Well, there's a bunch of different ways this can get more complicated. We could have rational and radical stuff to deal with, and I'll do that in another video. But the main way polynomials can get more complicated is to have higher degree terms. Now, we saw that there is a formula for squared binomials, and then in generic form, a squared plus 2ab plus b squared. There is also a formula for cubed binomials. A plus b quantity cubed is a cubed plus 3a squared b that should be a 3 plus 3ab squared plus b cubed. If you have an minus, which you don't in these examples, but if you had a minus, it would be the odd b powers that would become negatives. And I'll just also write down the formula for fourth powered binomial. So a plus b to the fourth would be a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. These coefficients are binomial coefficients. They're derived from the combination formula, which may or may not be covered in your various classes. You rarely have to go higher than cubes. Honestly, you rarely have to go higher than squares, but occasionally you will get asked to do cubes. Very, very, very seldom might you get asked to do fourth degree powers. But I've never seen anything higher than that, really. But you can easily look up what these coefficients have to be if you need them, or actually just do the foiling and FOIL stuff out and you can get there. Now, if you had a problem like a x cubed function, you would just have to be careful that you applied the cube to your x plus h quantity cube. You apply the correct formula, and then of course you might have conceivably squares and other things going on in the problem that would again further complicate things, but nonetheless, everything would eventually simplify if you do the arithmetic correctly. It just looks uglier because there's more terms.